guys, we are starting on 8-2, which is multiplying and factoring. So if you'll get your notes titled and dated, we're going to go a few examples, and then tomorrow's video will build off of today's information. So when we are multiplying, we are going to be multiplying a monomial times a trinomial or a binomial. So remember, a monomial is either a whole number or a whole number and a variable. And a trinomial means that there are 3 terms. So the 5n would be considered a monomial times a trinomial because there are 3 terms on the inside. Guys, I'm only going to do a couple of these because this is pretty simple stuff, as long as you remember your exponent rules. So what we're going to be doing is very similar to distributive property. You're going to take the monomial on the outside, and you are going to distribute to each term on the inside. So you have to be careful to remember your exponent rules, though, because with variables that have exponents, or with whole numbers that have exponents, whenever you are multiplying, if they have the same base, you need to keep the base the same and add the exponents. So I'm going to actually write this one out. I need you to on your notes also. This will be the only time we have to do this. So we're going to take 5n times 3n cubed. So you're going to want to multiply your whole numbers. So 5 times 3 is 15. And since n cubed has the same base, we're going to keep the base the same and add our exponents, so that we get 15n to the 4th whenever we distribute that 5n to that first term. The second one is going to be 5n times negative n squared. So negative n squared, we could put a 1 there, so that when we take 5 times negative 1, we get negative 5. And then n times n squared is n cubed. And then 5n times positive 8 is going to get us a positive 40n. You should have these written in standard form so that your highest exponent is written first. So 15 n to the 4th minus 5 n cubed plus 40n is our final answer on that one. So you're just basically distributing, which we should be really good at, but you have to be careful of your exponent rules when it comes to those exponents on these problems. So here's the second one. We're only going to do 2 or 3 of these, and then we're going to move on to factoring. Sorry about that. So we're going to take negative x cubed times 9x to the 4th. So guys, I'm going to go ahead and put a negative 1 in here so that I remember to multiply all my whole numbers by a negative 1. So I'm going to take negative 1 times 9 and x cubed times x to the 4th. So I get negative 9 for my whole numbers and x to the 7th for my x's. I'm going to take negative 1 x cubed times negative 2. Guys, make sure you take those signs with it. So we get positive 2 x to the 6th, because we're adding those exponents. And then negative 1 x cubed times positive 7. So we get negative 7 x cubed. As long as it's written in standard form, we'll be done. Guys, these are pretty simple problems here. They're pretty simple, but we have to be careful of our signs, and we have to make sure they're written in standard form and remember our exponent rules. All right, I'm going to go ahead and go on to the next part of this, which is finding the GCF for a problem. So hopefully you remember that a GCF stands for greatest common factor. So what you will find out is that a lot of this with polynomials works backwards from one another. So whenever we just distributed in these on the outside last problem, we're going to find what we could pull out for the greatest common factor on these next problems. Okay, so we have 5x cubed plus 25x squared plus 45x. So guys, these are when your multiplication factors are going to come in real handy. So I'm going to break apart each one of these. So I have 5x cubed. So that's the same thing as 5x times x times x. I'm going to break apart 25x squared. So to get 25, I can take 5 times 5, and then x times x. And then for 45x, I can take 9 times 5, but 9 can break apart into 3 times 3, and then just x. So guys, you're looking for what is the greatest common whole number and exponent and variables that these have in common. Well, since this one only has one x, I'm only going to take out one x for my greatest common factor. Since this bottom 145x doesn't have another x in it, I can only pull out one x from there. Then with my whole numbers, since this first one, since 5x to the third only has one whole number, only has one 5, that's going to be the most that I can take out from all three of those. So the GCF for this problem is going to be 5x. Guys, and that's all the answer is when it says find the greatest common factor. Now in the next video we're going to end up building off of this, but for right now, all I'm going to ask you to do today is to find the greatest common factor for each of these problems. All right, let's do another one. Now in your notes, and on I'm going to be specific on a couple of the problems on your homework. I want you to actually write out the problem. So write out each of those terms just like I did. All right, so what I mean by that is I need you to write out and break apart each one of these. So that first one we'd have 3 and then x times x times x times x. The second one we'd have 3 times 3, and of course one of those would be negative, but we're just going to leave it like that for right now. And then on this other one we would have 3 times 4, but 4 can be broken apart in 2 times 2. So that is these all broken apart. So our GCF here is the whole number of 3. And since this only has one x, we can only pull out one x for each of these. So our GCF is going to be 3x. All right, we'll do another one. I want you to pause the video this time, and I want you to see if you can figure out what our GCF is, and then play the video to see if you are right. So we're going to break this apart. For x to the 5th is going to be 2 times 2. X, 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 x. 24x cubed is going to be 4 times 6, which is 2 times 2 times 2 times 3. And then 8x, notice I left the negatives off because we could make any one of these negative. 2 times 2 times 2 times x. So for x's, I can only use one x. Oops. So that's in my final answer. And then on this one, I can actually take 2 2's from every single one. So 2 times 2 is actually 4. So our GCF is going to be 4x. Guys, it doesn't always have to have a whole number and a variable. Some of them could just have a whole number or could just have a variable. Okay. So on your homework tonight, some of them could just have a variable or could just have a whole number. All right, we'll do one more. All right, so on this one's a little more complicated because we have 2 variables in each one, okay? So I'm going to break it apart the same way I have been. So I have A times A times A times B times B. There's no whole number there. So guys, the first thing that you should notice is that you're not going to have any whole number in your GCF. 2 times 3 times A times B, and 11A squared. I can only have 11, or 11 times 1, times A times B times B times B times B. So none of the whole numbers are going to be my GCF, okay? So the smallest amount of A's I have are 2 and these 2. And this one also has 2. So A times A is A squared. And since this one only has one B, I can only take one B out as well. So my GCF for this problem is A squared B. It's the highest amount that I can pull out of those. All right, as always, if you need to go back and watch any part of this, feel free to do so. Rewind, pause at any time. Okay, make sure you raise your hand and show your notes, okay, so that you can get your worksheet.